Welcome. This is 8.6 notes, and yesterday at the end of the lesson, excuse me, at the end of the video, I started giving you a look into how we solve for this. The whole point of using logs is to solve for those exponents. So that was kind of the big reveal of why are we doing this. Okay, so today we're going to continue with the same idea of solving, today and tomorrow, but we're going to take it to different levels, and we're going to see a lot of different situations that we need to be able to react to and solve. So yesterday we said, let's say we had this 2 raised to the x power equals 31, let's say. We said, how do we get this x alone? Well, we know we want to get rid of the 2, so we log base 2 each side. Right? And then these are gone, and we're left with x equals log base 2 of 31. Now we put that in our calculator as log of 31 over log of 2. So we go to our trusty calculator. Log of 31 divided by log of 2. And I get 4.954. So equals x, which equals 4.954. Alright, so that's what we talked about yesterday. Now, there's going to be some situations that it doesn't always work out so nicely. Alright, so let's look at this one. 36 raised to the x minus 9 equals 6 to the 2x. Now, whenever you see this relationship, okay, if you can write them with the same base, it's a lot easier. So can I write 36 as a base of 6? Well, yeah, 6 squared is 36. All right, so we have 6 squared, but we can't forget about the x minus 9 up there, so I'm going to put it in parentheses, and this side's going to stay the same. Now, there's no need to log both sides because I have the exact same base, so I know my exponents are equal. So 2 times the quantity x minus 9 is equal to 2x. Distribute your 2, and when you subtract 2x from both sides, you get negative 18 equals 0, which we know cannot be true, so this problem is no solution. Alright, so just like solving equations, just like solving systems of equations, just like solving radical equations, anything, okay, we can have situations that actually don't work, so it is possible to get a no solution. Alright, so I'm going to do about 4 or 5 more examples with you and just kind of show you all the things that can happen and how we react. Alright, but basically now you know everything. Now it's just being able to do it. So 25x minus 1 equals 125 to the 4x. Now you need to ask yourself, what's better here? Can I find bases that are the same, or do I need to use the notation of log? Alright, in this case, we have 25 and 125, which are both powers of 5. So I have 5 squared is 25. Don't forget about your x minus 1. And 5 to the third is 125. Don't forget about your 4x. Your bases are the same, so your exponents are equal. So I have 2x minus 2 equal to 12x. Subtract your 2x. Negative 2 equals 10x. Divide both sides by 10, and x is negative 1/5. Alright, not so bad. Okay, what about this one, number 4? E to the 2x equals 6. Alright, now I can't change 6 to a base of e, so now I have to log both sides, but when working with e, our special number there, remember the inverse is the natural log. So we're going to natural log both sides. So I'm left with 2x equals the natural log of 6. Then we would divide both sides by 2. So in your calculator, the natural log ln of 6 divided by 2. And you get 0.896. 0.896. All right, so be able to work with E. All right, plugging along. Let's look at number 5. 3 to the 2x plus 5 equals 12. So, subtract your 5. 3 to the 2x equals 7. I can't write 7 as a base of 3, so I got to utilize my log notation. So log base 3 both sides. And you're left with 2x is equal to log base 3 of 7. So 2x equals, in your calculator, log of 7 divided by log of 3. And then whatever that result is, we're going to divide by 2. So log of 7 divided by log of 3 equals, divide by 2, okay, 0.886. 0.886. All right, good stuff. A few more. 6, let's say 6. Negative 3 e to the 3x minus 6 equals negative 8. Woo! All right, so let's get that 6 out of there. Let's add 6 to both sides. So negative 3 e to the 3x is equal to negative 2. Divide by negative 3. So e to the 3x is equal to 2/3. Now I got to get rid of my e, so I'm going to natural log both sides. So 3x equals the natural log of 2/3, which I'm going to eventually divide by 3. So we have the natural log 2/3 all divided by 3. And I get a negative number, which is fine. X is negative 0.135. All right, because I took the natural log of a very small number. Okay, so not so bad. Excuse me. What if something like this happens? What number are we on? Number 7. What if something like this occurs? Log base 3 of x plus 5 equals 2. Now in all the problems that we've done, our x has always kind of been up here. What happens if your x is attached to your log? I need to eliminate all this noise. And how am I going to do that? Okay. Well, just as log base 3 eliminates this, all right, so let's formalize this a little more. So I have 3x, and let's say I have log base 3 of x. All right, so to get rid of this, I would log base 3, and that is gone. Now, to get rid of this, what you have to do is take it 3 to this power. All right, remember I showed you that earlier? All right, but it didn't really have much meaning. So to undo this base, okay, we log base at both sides. To undo this log, all right, we need to raise it to that power with a base of 3. All right, so over here, what I'm going to do is I'm going to take this side put a base 3 under it, and take this side, put a base 3 under it. So now this is gone. I'm left with x plus 5. And over here, I'm left with 3 squared, which is 9. And then I subtract 5 from both sides, so x is 4. All right, so that can occur too. So now we have 2 different types of solving problem. We know how to get rid of the base of the 3 when we're looking for the exponent, and now we know how to eliminate the log when we're looking for the of piece, right? Log base 3 of x. That's what I mean by the of piece. Okay, now tomorrow we're going to take a step further and talk about extraneous solutions, but for now, we're going to take a day and just really focus in on this solving, and then we'll be good to go. All right, thanks. See you in the morning.